So, kia ora koutou, no mai haere mai. You are in low waste manufacturing now, and I am delighted to see so many people here. Now, one of the things that we have been doing through this series of Christchurch Conversations towards 2030 is to acknowledge that some people are going to live more of their lives in a changed climate and a seriously changed climate than others of us. Looking at the colour of my hair. So William and Ben, we have invited you to present a young person's vision for Christchurch of the future. And William and Ben are actually UC product design students and have a few other strings to their bow. So I'm just going to throw straight to you guys after very briefly saying hello to David Scobie, who is Business Development Manager at Concision, a Christchurch local company, and to Anthea Madill, who I think of as a serial eco-entrepreneur, really. Anthea is the brains behind Remix Plastics and also the co-founder of a new company called EcoSplat. But first, William and Ben, you have a few minutes only.
Excellent.
I think you just need to allow me to share my screen.
Ooh, this is it. Oh dear. So I should have done this already.
Cool, here it goes. Can everyone see it? Cool.
Cool, let's crack into it. Right, so kia ora everyone, thanks for coming. My name is Ben.
I'm William, and we're co-founders of KiwiFibre Innovations. So we're a startup looking to design a better world through smarter materials.
And as well as this, we're also students. And as young people, we really recognise the problem that we face and the responsibility that our generation holds in relation to our environment. Now, obviously, there's no quick fix, otherwise it would have already been done, to solving our environmental problems, but rather a huge list of small things that we can do. And one of these small things, which is actually quite a big thing, is working towards zero waste.
So we believe zero waste starts with better products and smarter materials. So we come from an industrial product design background. So our everyday products, like everyone has been saying, they don't need to have such a short lifespan as they do. And they don't need to be made of materials that cannot be recycled or reused. Now, a combination of these things is why we have so much waste and why it's becoming such a big problem.
So our solution is to essentially design out waste and create circular economies of materials across a range of products and a range of industries. These considerations need to be prioritised across the board, and our intention is to bring the fast-growing biomaterials industry to New Zealand.
So natural fibres used to rule the materials world. Then plastics, carbon fibre, fiberglass, polyester came along, and that makes circular economies nearly impossible. So now technology is developing, and the world is desperately needs more sustainability. And natural fibres are starting to be used again in growing biocomposite industries.
So this has enormous potential for not just new products and ideas, but also huge potential for starting to address our waste and environmental problems. So for example, the energy inputs required in producing a biocomposite are around 30% of that of synthetic composites. Given their lower density, they even perform better than many environmentally damaging counterparts in a lot of product applications.
So does anyone know what this is? It's flax. Wrong. It's actually a lily, and it's called harakeke. So harakeke has the potential to compete with overseas natural fibres. It's stronger, lighter, it's more sustainable. So unlike flax, harakeke is not intensely farmed. It grows in unproductive lands, protecting the waterways around it.
So we envisage a circular economy of materials spread across a wide range of product applications. If we can bring materials into circular economies, products can have a life after their end of life. But for this to happen, we need to design it in. This starts with looking how and why we design products and introducing natural and or biodegradable materials into products starting now. If we can make these circular economies of materials now and prove to the world that they will work, then I believe that leading up to 2030, we can start to flatten the curve of environmental damage that has already been done.
So this brings us to our circular economy story. So an example of this in action is our harakeke tahi board. A product that is uses one of our KiwiFibre materials, which combines recycled plastics that would have otherwise ended up in landfill and combined with Harakiki fibre. The benefits of this are it makes the plastic go further, enhances the properties, including durability, lightweightness, and can be recycled and reused in countless products after they reach their end of life.
Plastic, as you'll know, is one of the most polluting materials that there is. But it's actually almost one of the most recyclable as well, if it's managed properly. The material in this skateboard, for example, is 75% recycled plastic and 25% Harakiki fibre. Our bioplastic is designed to eliminate waste, replace wasteful materials, and perform even better than synthetics. We plan on applying the same methodology to industries like automotive, marine, sports, construction, and even aerospace, but the skateboard is just the beginning.
So the purpose of our first products like the biocomposite skateboard is to paint a holistic picture of what a circular economy of materials could look like, and to prove to the world that we don't have to produce as much waste as we do. Circular economies of materials will be a solution in more sustainable material flows moving into the future.
Otatahi is the perfect proving ground for this. It is a thriving startup community, and with the whole of the South Island at hand for potential plantings and supply chains, it's the perfect place to build Aotearoa's first circular economy of materials. Thanks for listening. Feel free to visit our website and follow our journey. Cheers.
Thank you both. So at this point, I'd like to bring in Anthea first, actually. Anthea, in the context of your businesses, you have often used material that would otherwise either have gone to landfill or might have gone to recycling. What do you see as the place of recycling in the whole scheme of low waste manufacturing? Like what, and why did you end up starting a business that actually used plastic?
Kia ora, everyone. So my answer to that has already actually been said quite a lot already today, is that we need to redesign the system. And so recycling isn't the answer. I think it was initially seen as the solution for waste, but now we can see that it's way more complex than this. We need to...
Sorry. Anthea, for you as a business person, I know you've said to me personally that it in many ways, especially the earrings, the beautiful earrings that you do, it wasn't the earrings themselves, it was a bigger story. Just tell us a little bit more about that.
Yeah, so my work is focused around sustainability education, so educating people about these problems with zero waste and how, like, the problems with the system in general. And so for me, the main goal isn't to divert heaps of waste from landfill. Obviously earrings are quite little and it's only going to use so much, and even with the thousands of pairs of earrings that I've made, it's still a pretty small amount of plastic diverted. But I see plastic recycling as a way to engage consumers in that conversation who wouldn't necessarily otherwise be thinking about it. And so this can be people that are wanting to be conscious consumers, and then I can sell that they can buy a product that is sustainably made from a recovered material, but then it also has all of that story with it. So and especially with things like the ice cream container lid stuff that I make, is that the plastic that's made from can theoretically be recycled, but doesn't get recycled in Christchurch. And so that's a way that I can explain some of the problems with the current stuff that we have.
Can I bring David in here? David, Concision technology effectively can significantly reduce the amount of building and construction waste. Can you tell us just a little bit about that and where you fit into the sort of waste minimisation, low waste manufacturing picture?
Thanks, Michelle. Concision is an off-site manufacturing company, and we use technology to build a house, essentially. So we have a series of computer software programs, CAD works and BIM models, and through that we optimise the use of raw materials. So, for instance, when we design a house, that goes into our modelling scheme, and it works out how much timber it's going to use and how it's going to cut that out of our available stock of timber. We then release that to the factory, and for instance, on our CNC saw, it actually then starts to look at several houses that we're building and understand how we can optimize the timber throughout all of those buildings. And that means that typically in a house, in our factory, we'll have about 2.5% waste of product. It does the same for jib board and rab boards and all the other materials we use. And that effectively means for a standard house that a Concision house would be about a third of the waste produced as a normal building would be. So we take, I suppose, a manufacturing approach. If you look at the amount of waste that's generated in the construction industry, a company like Toyota would never be in business if it was generating that amount of waste. So we've taken that sort of philosophy and said, actually, we need to apply that into the building industry and come up with ways of just eliminating the waste in the first place.
So one of the things about yours that is striking is that you're tackling a very wasteful industry. In fact, that when we talk about building waste, it's waste that never actually gets used, does it? It's unused material going straight to landfill.
That's correct. I mean, so the waste that would normally occur in building a house is almost unforgivable waste in the fact that it's never actually had a useful life to start with. The tree was cut down, it was cut into timber, it went, and it never got to be a house. Its purpose never actually happened. It went straight from going through a whole process, all the raw materials, the energy put in to convert a tree into a piece of 90 by 45, and then at times up to 25% of it would get chucked into the skip before it actually ever got to be put into a house.
Quick thoughts from all of you, 30 seconds each, on end of life. What can we do for end of life of your materials?
Oh, not myself. Sorry, I was
Ben and William, Paul has posted a question specifically. Can your composite material be recycled at end of life?
Yes, it can. So the types of plastics that we're using are thermoplastics, which means that they can be remelted and remolded into a new product, theoretically, like as many times as you like. After about 10 times, the materials start getting weaker, but it can still be used for different applications after that. So, yeah, it's pretty circular if you treat plastic correctly.
Did David or Anthea want to comment at all?
On end of life, it's interesting in that a house can last for an extremely long time if well looked after and well maintained, and as we talked in the last group, repaired and looked after. But quite often a house is pulled down, and I'll use a term for aesthetic reasons. So somebody, and especially it happens in Auckland where they buy I'm not banging Aucklanders, but a house is brought, they demolish the old one to put up something which is better. Whether the house that was there was probably perfectly good. A house should only be repaired, ripped down when, I don't know, the woodworm has eaten the wood, not beforehand, and then that wood is obviously of no use at that point. But I think a lot of times we don't need to demolish houses the way we do.